Now, I will explain how to use the Minitab statistical software for implementing the P control charts for attributes type data. For this purpose, please reconsider the frozen orange juice example where we were counting the number of non-conforming cans in samples of size 50. The data is given in the Minitab worksheet where we have two columns. C2 is the sample number and C3 is the number of non-conforming cans or the DI values. In this example, we will use 30 samples, as can be seen here, for the phase 1 implementation of the P control chart. Basically, we will identify the control limits and the center line to be used in phase 2 implementation of the control chart. To implement the P control chart, we need to go to Start. Again, select Control Charts and select Attributes Charts where you see the P here. As alternative charts, you can see the NP chart, U chart, and C chart, which can be implemented in different instances. For this example, let's consider the P control chart. First, for the P control chart, we need to define the variables. In our example, our variables are in column C3, number of non-conforming cans. So I select that. Subgroup sizes should be entered. In our example, the subgroup sizes are 50. Then we go to P chart options. We can either consider the case where the parameters are given or the standard is given. In that case, we can enter the proportion here, the P value, as if it is known. If it is unknown, as in our case, we need to estimate that. In estimating that, we have two options. We can omit the following subgroups that should be written here when estimating the parameters, or the other option is use the following subgroups when estimating the parameters. As this is the initial stage and the first iteration, I will not write any subgroups that should be omitted. Therefore, I leave it empty. Again, one can define S limits as the standard implementation. I will consider the 3 standard deviations control limits, so I will not write anything here. By default, it will give the 3 sigma limits. We can consider different tests, as can be seen here, to sensitize the control chart. Stages can be defined, but this is the first stage, so I didn't use any label to indicate this is first stage, so I will not do anything. Display options are given here, and storage options are given here. Let's have the proportions, estimates of the proportions to be stored in this case. I click OK, and I will have the control chart. Now, in phase 1, we have 2 out of control observations. This is sample 15, and this is sample 23. 15 and 23 are out of control. Now, in a phase 1 implementation, we try to identify out of control cases. Our control chart indicates that there may be problems during the times the sample 15 is taken, or sometime before that. And of course, the same for the sample 23. So I will, for illustration, I will omit the out of control action plans, and I will simply assume that these 2 points are due to assignable causes of variation. So to determine the phase 1 control limits or design the control charts for process monitoring in phase 2, I will discard these 2 points, sample 15 and sample 23. Let me show you how to do that. I go to Stat again, control charts, attribute charts, P-chart. This time, with the P-chart options, for the estimate tab, I will write 15 space 23, and this indicates that we will omit the samples 15 and 23 when estimating the parameters. So let's do the recalculation. As can be seen, now in our calculations, we didn't have these samples 15 and 23 used in the calculations. The control limit, especially the upper control limit, got closer to the center line, and we have a new point, sample number 21, being out of control this time. Now I will assume that this is very close to the upper control limit, and I will assume that our studies indicate that we don't have any assignable causal variation that is attributable to this point. So simply assume that this is a normal behavior of the process. Therefore, we have the upper control limit of the process to be 0.3893. We have the center line at 215, 0.215, and we have the lower control limit at 0.0407. This is our phase one implementation. By assuming that this is this is a normal behavior, and I don't want to discard this point, I stop the iterations. So I will use this revised control limit, upper and lower control limit, in phase two. So let's continue, and let's remember this value 215. I already have some other data for you. Let's continue with another data set. In this data set, in addition to the phase one sample here, I inserted a stage identifier label, and using this label, I separated the two types of observations. Stage one corresponds to the data observations that we used in phase one, and here we have, after the observation 30, we have stage labeled as 2, which indicates that this is phase 2 observation. So we have a total of 54 observations now in this data set. 30 corresponds to the initial sample that we used in phase 1, and the remaining 24 observations are for phase 2. Let's do how to, let's show how to implement this. Again, we go to Stat, Control Charts, Attribute Charts, P-chart. This time, with the P-chart options, I will define the proportion as if it is known, because in phase 1 we estimated it to be 0.215, if I remember correctly. Then I'm not gonna do any estimation. I will not do any changes for test stages. Maybe I can define the stages here to better show the graph, because it will separate the plot into two. Display, I don't want to store any information, so let's keep it like that. Let's see. So this is my plan. The first 30 observations, or first 30 samples, were used for phase 1 analysis, and this is the plot for that. And using by extending the control limits identified or determined in phase 1, we have the observations as shown here. And here we have an indication of an out of control point, which indicates a process improvement if we assume that it's an improvement. Here, as you can see, the most of the plots are below the center line. So this is basically, this chart requires some changes. So it would be better to use the second part of the observations for parameter estimation. So let's do an update of the control chart this time. I go to Stat again, control charts, attribute charts, P chart. I go to P chart options. This time I would like to estimate. I will delete the parameter given here because I want to estimate the new control limits by using the phase 2 observations. So what I will do is I will say use the following subgroups when estimating the parameters. So I would like to this time use the observations 31 through 54. So I write it like this. And using these remaining parts, I will do the estimation. Here, I don't want to show the data in stages. Or it can stay like this. Let's continue with this. So this is the plot. We didn't have the first part here, but I used the second part of the observations. So as all the observations plot within the control limits for the phase 2 sample, I will take these as the upper and lower control limits of the new process. So the new process average is 0.1108. Of course, we collect more data. This is an online process. Let me continue with the third data set. We have more data. So let's remember 0.1108 again. So this time I'm going to use the third data set. So we have another stage in this data set, stage 3, which starts with the 55 of observation 55th. So it continues until observation 94. So we have additional data. The first 54 observations are from stages 1 and 2. So I added some extra data for this. So let's do another control chart. We go to control charts. We go to attribute charts. We go to P chart. We select the number of non-conforming cancers are variable. We have subgroup size of 50. Let's go to P chart options. This time I will enter the near proportion as if it's known, 0.1108, if I remember correctly. To have a better plot, let's add the stage number given here. We will display all in one graph. I don't want to store anything, so I click OK. Another OK here. So this is my chart. The first, now the upper control limit is based on the sample of observations in this period. So we take the 24 observations in this stage, stage 2, and we use them to design the control chart. And now this is my new control limit. And if we continue with the new control limit, you will see that all the observations are within the control limits. Of course, this is our previous in control level. Now there's an improvement with the process. Basically, this is the machine adjustments that was performed somewhere around here. And after the machine adjustments, the process fraction defective has decreased. So we have about 11% defectives in this process. And the upper control limits are at lower values, and the process is in control. Again, the process is in control, but this does not indicate that the process is doing well. 11% defectives may be considered to be a high value, but this is just to illustrate how the control charts are implemented. Similar steps can be taken to implement the U chart. T chart or the NP chart.